All right, so today we're going to be talking about solving quadratic equations by factoring. So we've been building up to this for a while. Before we've just been simplifying. Today we're actually going to solve these equations. These are actual equations, they're not expressions. So we are solving some of these quadratic expressions, which a quadratic expression again is just something that looks like this, where you took two binomials and you multiplied them together to get this trinomial, right? This is a quadratic expression. So again, just real quick to start, when we're solving something that has a square root on one side, or it has a square on one side, you just square root it. And you need to have a positive and a negative answer. So x would equal either an 8 or x would equal a negative 8. Okay, but let's look at this one. We want to get x alone, right? Well, there's a reason why we did factoring. And that is, we need to get this all factored first so that we can look at, there's a quick, easy way to figure out what the two answers are going to be if we can get it in factored form. Okay, and this is where I talked about where there might be two different answers. That's where you're going to get today. So, first thing to do to factor it again, you look, see what the first times the last is, and it's 2. So you need to figure out the multiples of that would add together equal negative 3. Well, that'd be easy. Negative 1 and negative 2 multiplied together equal 2, but they also would equal negative 3 when you add them. So when we put that together, I could rewrite this as x squared minus x minus 2x plus 2. And then we can group them. Okay, and then take stuff out. So first one, I can take out an x. So that'll give me x times x minus 1. And then I can take out the negative 2. So plus the negative 2. And that leaves me with x minus 1. Okay? So rewrite that. I'm going to have x minus 1. And notice I'm going to put a space here. And x minus 2. Because in order to solve these, I'm going to set both of these equal to what our equation's equal to. Okay? That will give me what each of these x's would have to equal in order for this to actually equal 0. So to solve this, I would add the 1 to each side. X is going to equal 1. And then I'd add the 2. X is going to equal 2. And that is my answers. Not too tough, right? Well, let's look at a little tougher one. Let's look down here at number 12. So number 12, I'm going to break that down. And this one's an easy one because these are squares, right? 49 just be negative 7. That would be split into, so I'd have let's just break it down to be, well, I'll group it. X squared minus 7x grouped with plus negative 7x plus 49. Okay. Take out our common factors. You got a common factor of x. X squared minus 7. Take out the negative 7. So plus negative 7. X minus 7. Okay. We factor out the, that shouldn't be squared anymore. Factor out the x minus 7 now. So x minus 7. And then I get another x minus 7. This should be interesting. X minus 7. And if we set them equal to 0, I should get the same answer, shouldn't I? They would both be positive 7. Now, do I write x equals 7 twice? Does that make sense? Don't I just have to say x equals 7? 7 is the only possible answer here. Because even if I write it again, it's the same number. X can't equal the same number twice. I mean, it can if it's a different equation. But it's the same equation. You don't plug in 7, get an answer, plug in 7 again, get the same answer, right? You got to plug in both numbers to get that answer. So if it's the same number, you only have the one answer, x equals 7. Okay, let's look at another one. Let's look at number 17. You guys might get thrown a little bit by this one, but again, let's split it up. So 4 times negative 6 is negative 24. I need multiples of negative 24 that add up to 5. So one has to be negative, one has to be positive. It would be 8 and a negative 3. So when I split that up, split the 8 with the 4. So 4x squared plus 8x, and then minus 3x minus 6. Okay, factor stuff out. I can pull out a 4x. Leaves me with x plus 2. And then I can pull out a negative 3. So plus negative 3. Leaves me with x plus 2. So pull out the x plus 2. Have x plus 2 equals 0. And I'm going to have 4x minus 3 equals 0. So the x plus 2 one's easy, minus 2 to each side, x equal to negative 2. This one is a party problem, right? So you'd add the 3. Gives you 4x is equal to 3. Divide by 4. X is going to equal 3 over 4. And that is your answer. Not too tough, right?